Hi, welcome back. This time I'm going to try to have you be a little bit more independent with the setup of this stuff. So the first two examples I want us to go ahead and read through and then try just to make the normal curve setup. And when we do this, we're going to do it in two ways. Think about the last video. We put the mean and the standard deviation down specific for the problem itself. And then I identified the numbers 0, 1, 2, 3, and then -1, -2, -3. So we could be able to apply this both to the calculator and to the A2 trig reference table. So in number 2, in 1972, the heights of rugby players were approximately normally distributed, with a mean of 179 and a standard deviation of 7 centimeters. Find the probability that a randomly selected player in 1972 was, regardless of this question. I'm just getting us exposure to all the ways that we can try to be successful with a normal curve question. So take a moment and pause. Maybe reread this question yourself and then identify the 7 parts to the normal curve. Draw one in your sheet of in your notes and then identify what you think the parts are. Welcome back. Take a moment and check out what I have here. Hopefully this looks familiar. We'll see the 179 from our problem up above, and we're told that's our mean. I like to draw the mean right above it, just so I know myself this is the mean, and I don't make any mistakes. I also can then go ahead and write 0. Now, we know that there is a 7 centimeter difference for the standard deviations, and we know there's 3 above, 3 below. So with this, we know that 186 must be 1, 193 is 2, and 200 is 3 above. 172 must be 1 below, 165 is 2 below, and 158 is 3 below. That's a fun looking 3 right there. So initially, I just want to see if we can get this part set up, because it's going to be impossible for us to either use the calculator or to go ahead and use the reference table if we're going to be dealing with a trouble setting this up. Next, just for us, try to determine what you think the values would be. Draw this on our diagram for letter A. 175 centimeters tall, at least. So if we wanted to try to figure out what this is going to be, 175, roughly marking it on my diagram, is going to be right around there. And then I said draw a vertical line. Now this is a right-tailed problem because it's going to continue onwards and onwards, upwards, and so on from there. Now the first two examples I'm not going to solve. I just want to see the setup. But I also want to make sure that we can see in the language from where this is coming. At least means we start at that 175 and we move on. Go ahead then and insert example 3. Once you've done this, go ahead and mark on the diagram both what you believe the question-specific numbers are for the mean and standard deviation, and then go and mark down our -3, -2, -1, 0, 1, 2, 3. Pause the video and then come back to us when you think you've got it. Welcome back. Well, hopefully, does this look familiar? If it does, then you could be trying to say to yourself, perhaps this is feeling a little more normal to me than it did before. Well, with it, we're just trying to check out again in these initial times that you can understand the setup of stuff. So I'm going to take us to example 4. We're again trying to go and first let you get a chance and then have us try to just give a brief explanation. Have you go and stagger this one. So if you could, go ahead and set up the normal curve and then make an attempt for letter A1. So you don't need to answer anything more. Pause the video and then come up with an answer for letter A1. Once you unpause it, I'll have the setup here and the answer for us to look at. Welcome back. Okay, so we have a lot of stuff just thrown at you right here. But again, hopefully this is looking familiar. Looking at first my diagram. So in the diagram, I use this with a mean of 95 and a standard deviation of 8, both going up and down. And then noting we're looking between 87 and 103. So 87 is my -1 left bound, and 103 is my positive right bound. In this case, I put them into it. Now this should start feeling a little familiar. We have -1 to 1, and then 0.6827 is going to be my answer. So you might be taking a look at this and saying to yourself, hey, I'm starting to see the same type of trend, some similar pattern go on, where it's just about roughly like a 68%-ish between the first two standard deviations within. And then take a look at the second two, and you'll notice that it seems anytime, regardless of the context, you get about 95. And then look at the other one, and you'll notice that we get right about 99.7. Now this has various names to it. I usually know it as the 68, 95, 99.7 rule. Some people will say, well, let's get a little more specific. It's 68.3, or like we've got for an answer for letter A, 68.27. The point is, it's good to know what these general trends are. So within one standard deviation, 68% of the data will occur. Within two standard deviations, above and below, 95% of the data will occur. And within 3 standard deviations, above and below, 99.7% of the data is going to occur. If we get pretty good with this type of thing, it can become a lot easier for us to quickly answer these. And sometimes, depending on how much of a master you are, you do not even need to set up the diagram. You can be able to get there independently without having to even think about it. So I'm going to ask you to pause the video and answer the rest of the questions. And then only again, once you have done, join us back and I will make sure to explain what the solutions are, and hopefully this is going to be feeling a lot better with you in terms of its applications with normal curve and the area underneath it. Hi, go ahead and check your answers to our final video examples on the normal curve. In the second part of letter A, it asks for us to put it in terms of between 103 and 111. Again, quickly identifying this, we see that 1 to 2 is what I put in for an 81.86%. And then we are asked for between 87 and 111 in part B for a 13%.59. And you know what? I'm just realizing myself here that I switched these values, 81.86 and 13.59%. Switch them. If you caught that as well, it looks like I just happened to write them. And if you think about it, it's because in letter B, that's a much larger range, so we would expect a much larger number. Where in 2, a much smaller range, we are expecting a smaller number. But we'll just leave that mistake there because, hey, I mean, I randomly made it. But mistakes are good points to jump from because it can show us how, we can also learn from them, I was saying, in this case, from how big the spans or the range of the normal curve are. So now at this point, please go ahead and we are going to proceed to more independent practice, but always feel free to return to these videos if you have any further questions on the normal curve, its setup, and finding the area underneath it.